we were talking about constant motion. No, fully forward. Now let's start from fixed fully forward. Fixed for fully forward. Fixed fully forward. Here fixed word is added. Means pulley will be fixed. Pulley will be fixed from center. Okay, from center. In that case, what kind of a question are we going to take? Okay, uh, when pulley is fixed. So first question I would like to write over here. Question is find out the velocity of B when block A move with 10 meter per second, and figures is something like this. A object, B object, 10 meter per second, 10 meter per second, 10 meter per second, 10 meter per second. We have to find velocity of B, velocity of block B, and the angle is something like this, horizontal. It is making an angle of 53 with horizontal line. This is our complete question. Question is asking what would be velocity of block B. Find the velocity of block B when block A move with 10 meter per second. When block this A will move with 10 meter per second in this direction, in that case, what is going to be velocity of block B? That is what question is asking. Okay, we have to find this block B. Remember, block B. Try to understand. This is our string. This is also string. Okay, tension. Over here, tension. This is tension. This is tension. String. Each points on the string. Each points in the string will be how much? Same, 10 meters or 10 meter per second. This will be same for each points of a string. Okay, this was the first point. Remember, the A block, when A block will move with 10 meter per second, in that case, what will be velocity? With how much velocity block A will move? This is what question is asking. Now again, focus over here. You tell me. First of all, remember, if a block A, velocity of a block B, this will be more than this angle. Tension. Let's say tension. Then what will happen? Remember. And velocity of B is less than T. Then what will happen? Remember, if velocity of B will be more, then slack what will come? Then this string will slack. This string will slack if velocity of B is more than tension. Okay, more than tension. In that case, more than this velocity, more than 10 meter per second. Okay, let's say this is our V. Clear? In that case, our string will slack. If this V is more than velocity B, then what will happen? String will break. This string will break. But question will not provide like that condition. Okay, like that condition. Question will say that whatever will be value of this string, value of velocity of string will be also for block. So it is the same that velocity B should be equal to V. Whatever will be velocity of the string will be also for block. Okay. So that our string cannot break and cannot slack. Okay. That's why we will consider this velocity of B as a 10 meter per second. Okay, 10 meter per second. 10 meter per second. So question is asking. Remember there is a no relative motion. No relative motion. No relative motion. This is our VB cos theta. Okay, VB cos theta according to this angle. So this VB cos theta will be also for perpendicular. This is the meaning of a no relative motion. So VB cos 53. VB cos 53 will be equal to 10 meter per second. 10 meter per second. Try to understand. We over here we said that whatever will be velocity of a block will be equal to this resultant. Okay, resultant. But here you have to be careful. You have to be careful. Carefully that we don't care. We are not going to care about relative motion. Okay, when it comes to polyformat constant polyformat. Okay, relationship between velocity, acceleration, displacement. Okay, then we are not going to care about components. So whatever will be velocity of this direction B will be also equal to resultant, this stream. So finally your velocity will be how much? Cos 53, 3 upon 4, 3 upon 5, 3 upon 5, 10, 5 multiple 3, 53. So cos 53 is our 3 by 5. 3 by 5. We can write cos 53. 10 upon 3 by 5 multiple 5. 5 by 3. Your answer would be 50 by 3. 50 by 3 meter per second. This is our velocity of B. Means with this much velocity, our block B will move. When block A will start moving with 10 meter per second, then in that case our block B will move with a velocity of 50 upon 3 meter per second. Okay, this was our first question. In this question, just you have to remember that we will not care about relative motion. Whatever will be according to theta, whatever will be our B cos theta will be also this one direction will be equal to this is a tension string, velocity of a tension. Now next question. Not the component of velocity. The component of this velocity must always be done along the string. Means this V cos theta should be along with the V velocity. This is the first point. Okay. Next, never make components of a string velocity along the direction of a block's motion. Okay, means never take like this. If VB cos theta is for only this, no, VB cos theta will be also for this. Okay, this will be equal to 10. Never break. In short, never break. Next. Next over here. relation V1 and V2, relation V and V2, where figure is there is a roof. This pulley is fixed at center. At center. At center. There is a surface of Earth. Now, this velocity is moving with V2, and this V2, V1, and angle over here is a theta 2, and angle over here is a theta 1. Okay, theta 1. Question is asking what would be relation between V and V2. V and V2. According to you, what do you think? What should be the relation between V and V2? Both are velocity, but V1 is a velocity of this A block, and V2 is the velocity of B block. Tell me what should be relation? What should be relation between them? First of all, don't care about relative motion. Okay. Second, never take components for the specific direction. For example, here our V2, according to this data, this will be our V2 cos theta. But this will be also, let's say, this will be also V2 cos theta will be equal to velocity of a tension. Okay, so this V cos theta 2 will be also for this tension. V2 cos theta. Okay, according to this angle, this don't care about the direction and relative motion. So this will be our V1 cos theta 1. So this will be equal to velocity of a tension. V1 cos theta 1. This is also for this tension. Okay, this tension. Now you can write like this. V2 cos theta 2 is equal to direction is same. Again I am telling you, don't care about the direction, don't care about the components. Just take one component which is with theta. So this one component V2 which was with theta. This another. So V2 cos theta. V2 cos theta will be equal to V1 cos theta. V1 cos theta. Okay. This will be our equation. This is our relation between V1 and V2. Okay, V1 and V2. Remember. Reverse. We just took the reverse of this V1 like this. Okay. So like this you will bring your relation. Now next question. 31. Relation between A1 and A2, where figure is looking like this. This is attached with wall. This rod is attached with wall. A2 is over here. This is our isolation. Okay, A is isolation in this case. acceleration is downward, A1, A1, M broke. Theta is over here. This is our theta. Theta will be given by the equation. So don't need to care about theta. Okay, theta will be provided by the equation. Now question is asking what would be the relation between A1 and A2. So remember A is over here, A is a relation. In the first question we have also velocity. Method will be same, concept will be same, nothing is different. Let's see what is going to relation. So over here A2, this A2 component of this A over here is with this theta. So can you write A2 cos theta? Reason is this is with this. Okay, A2 cos theta, A2 cos theta. Clear? Don't care about relation motion and adaptation. And A1 is this is our A1. This is A1. Remember, direct acceleration in this string will be how much? A2 cos theta, A2 cos theta, A2 cos theta, and A2 cos theta, A2 cos theta. You are saying that A2 all the time at each points of the string will be how much? Same acceleration will be there. Okay, same acceleration. This is so over here A1 will be equal to A2 cos theta. Reason is over here at this point acceleration will be same. So A2 cos theta will be equal to A1. This is our relation between A1 and A2. Clear? Now next question. Next. Find the relation between VA and VB. Your figure will be this. There is a rod which is attached. This is not attached, but it is. We just keep this rod in that way. A point. This is one point of a rod, which name is A, and second end point is B, which name is B. And over here theta is theta. This angle is theta. So velocity downward of A point is VA downward. This is our y horizontal, x horizontal, and in this our velocity is VB. VB. Try to understand what is it telling you by the figure. Question is asking V and to V2, velocity of A point and velocity of B point, and figure is trying to tell us that there is a rod, and you have to focus on 2 points of the rod, first ending point and second starting point. This is starting point and this ending point. Just focus over here. So what is happening over here? This will come downward. Reason is velocity of A is a downward. So this A point will come downward, and B point, velocity of B point is a forward. So this B point of the rod will go forward in this direction. This is what will happen. Okay, this is what will happen. Now my question is at the end what will happen? At the end this rod will be horizontal. Am I right? Over here we can see velocity of A will be equal to velocity of B. Reason is Reason is, with the same time both points will move. At the same time, velocity will be same. Try to understand. If this A point moves over here, then B point will be over here. Same displacement. It means we are saying let's explore it one by one. So what theta is over here, this will be our VB cos theta. VB cos theta. So VB cos theta will be equal to this, let's just say this is our result. So VB cos theta will be equal to velocity of a rod. Velocity of a rod, which will be equal to velocity of a. Velocity of a. So if this is theta, this will be our 90 minus theta. Not 90 minus theta, but 90. So this will be our 90 minus theta. There is also angle. So if this is angle, it is just opposite, 90 minus theta. 90 minus theta. If you take cos, so cos 90 minus theta will be your sin theta. Sin theta. So VB cos theta will be equal to VA sin theta. So just we converted cos 90 minus theta into sin theta. Okay, everything is same. Everything is same. Here we were getting angle. That's why we wrote VA in VA as a VA sin theta. VA sin theta. Now try to observe. You simplify this further. Okay, just to simplify this further. So VB upon VA will be equal to what? Sin theta upon cos theta, which is equal to tan theta. Am I correct? So finally you can say tan theta will be equal to VB upon VA. If you want to find the angle, this angle or this angle, then just you can say tan theta, and over here VB, this we are taking as a perpendicular upon base. So tan theta perpendicular upon base. So here our focus is not on perpendicular. Just it is saying tan theta will be equal to VB upon VA. Okay. From this equation we can get velocity of A, velocity of B, and angle as a number. Angle as a number. Clear? Angle as a number. As you know, this is a right angle triangle. Can you write? Let's just say length of rod is L. Okay, and this is our x from origin to B point is x, from origin to A point is our y. So you can finally write like this: L square is equal to x square plus y square, where L is a hypotenuse. We are considering just L as a hypotenuse. It can be written as. Now remember, we are going to solve this by calculus method. When it comes to calculus, it means we are going to apply differentiation and integration. Okay, differentiation and integration. Just differentiate this equation with respect to time. Okay, differentiate it with respect to time. Then see, first of all, L is a constant. If L is a constant, depreciation of L2 will be 2L, and depreciation of the x square will be 2x, and depreciation of 2y will be y square will be 2y. This equation we will get. if L is a constant, remember, L is a constant. L is a constant. Then L will be our 0. dL upon dt will be our 0. dL upon dt will be our 0. Here you will get tan theta is equal to y upon x. Y upon x. We will say it later. Right now, let's move towards. Let's move towards moving pulley format. Moving pulley format. Moving pulley format. Now pulley will be movable. Pulley, one or two pulley will be moving. Okay. And first will be fixed. For example, this is our pulley, which is moving with a P. VP velocity. Velocity of pulley is a VP. There is a two blocks, which is attached with a pulley. There are two blocks like this. A block, B block, and the velocity of A block is upward, which is VA, and velocity of B block is also upward, which is a VB. Okay, this is our figure, complete figure. Remember, over here, this pulley is movable. Okay, moving pulley. It means pulley is moving upward, direction is upward. So with how much velocity pulley is moving? With how much velocity block A is moving, where pulley is also moving. So with how much velocity block B is moving, where pulley is also moving with some velocity. In that case, our equation will be different. Whatever we saw just before it will be valid when pulley is fixed. But right now pulley is not fixed. So let's see what kind of condition will we get. This is our figure. Remember, when observer sit on the pulley, means with reference point is pulley. Okay, if a reference point is pulley, when observers sit on pulley and observe block A with respect to block A and B with respect to pulley, means reference point is a pulley and pulley is observing block A and block B. In that case, remember, in that case, VP, velocity of VP will be downward according to pulley. Okay, pulley is a reference point. Over here also VP will be downward. Who is observing? Pulley is observing. Okay, and velocity of A with respect to P, velocity of B with respect to P will be upward. Okay, but the velocity of P will be downward according to pulley, which is moving. So velocity of A block is moving upward. Velocity B block is moving also upward. but velocity of a pulley is going downward. Okay, this is what is happening. In that case, you can write this velocity A with respect to P is equal to, direction is also same. And you can see blocks, masses of the blocks are also same. I think so. So velocity of B according to P will be equal. This is the first. Reason is direction is the same. I think magnitude will be also same. If a magnitude is also same, then we can say yes, both will be same. Now try to observe. Velocity of A minus velocity of P. Direction. Try to observe carefully. Velocity of P and velocity of A. And according to pulley, velocity of P, direction of velocity of P is a downward, direction of velocity of A is upward. So that's why for negative, upward will be positive, downward will be negative. So this velocity of A is upward, it has a positive, and velocity of P, which is a downward, it has a negative sign. Okay, this will be equal to minus velocity of B minus velocity of P. Try to just we applied what? Just we applied negative sign. So velocity of B is upward, positive sign. Velocity of P is a downward, which is negative sign. Now both can be written as velocity of A minus velocity of P is equal to velocity P minus velocity B. This equation you will get. Just to see, velocity of A block is upward minus velocity of B is a downward is equal to velocity of P is a downward and velocity of P is a upward. Okay, sign is the same. Just we applied with negative sign. At the end, you will get a equation which will be equal to velocity of P will be equal to from this equation. You will get the velocity of A plus velocity of B upon 2. This is our final. If we will use this equation to calculate velocity of P. You can also calculate velocity of A, velocity of B by using this equation. Okay, yeah. Just remember, velocity of P, which is moving, will be equal to total velocity of A block and B block. Okay, upon half 2. Okay, 2. Same. This is the same for acceleration, same for displacement. Yeah, you can see acceleration of a pulley will be equal to acceleration of A plus acceleration of B upon 2. This is acceleration and displacement. Displacement of P will be equal to displacement of A plus displacement of P will be equal to 2. Okay. Everything is same. Just replace A, acceleration, X. That's it. If equation is asking velocity, then use this first equation. If equation is asking acceleration, then use the second equation. If equation is asking displacement, then use this equation. It's your choice. No. According to equation, we will use one of this equation. Clear? I think we have crystal clear about all this equation. Now it's a time to take question based on concept. Based on concept. Find out the velocity of a block. A block. There is a block. This pulley is moving upward with 20 meter per second. If a pulley is moving upward with 20 meter per second, in that moment, what will be velocity of a block? Okay, a block. This is what question is asking. Question is asking. A upon 2. A upon 2. End velocity is 0. Final end velocity is 0. It is talking about this final. So answer will be, just we are going to use our equation, whatever we saw just before it. Okay, so fixed and velocity. Fixed. This fixed end velocity. This fixed end velocity is a 0. Okay, this is a 0. Okay. So velocity of P will be equal to velocity of 1 plus velocity second velocity upon 2. Velocity of a pulley is given, which is a 20. Velocity of a first this which is a fixed is a 0. Second velocity of a block is a nothing, v2 upon 2. So 20 is equal to v2. So you can say it is moving upward with a 20 meter per second. Hold on. 40 meter per second. V2 is equal to 40 meter per second. This is our answer. It means it is also moving upward with a pulley system. With a 40 meter per second. Clear. Upward. How did we recognize that this is moving upward? We recognize with the help of a sign. Sign is a positive. Positive is for upward and negative is for downward. Okay. Now next question. Found out VB. One pulley is fixed at the center. But second pulley is moving by taking two blocks. Block A and block B. Second. So block C, block D. Remember, block D is moving with 6 meter per second and block C is moving downward with 8 meter per second. Block A is also moving downward with a 2 meter per second. This is our question as a figure. As figure. Question is asking what is our velocity of this B block. Okay, B block. Let's say X, Y, Z. These are names of pulleys. So X pulley is not moving, it is fixed. Y pulley is moving. Z pulley will be moving. Okay. Block A is moving downward. Block C is also moving downward. Can we use this formula? Block A plus block B, velocity VB, VA plus VB plus VC plus VD upon 2 or upon 4 or upon 4. Just take this one pulley, okay, one pulley. So over here V1 will be equal to 8 minus 6 upon 2. 8 minus 6. So 8 is downward, 6 is upward. So 8 minus 6 upon 2. Or you can say minus 8 plus 6 will be our minus 2. So 8 minus 6 upon 2 will be V1 1 meter per second, which is a downward. Same over here. V1 minus VA plus VB 2. Here, just we are taking this block A as a minus, which is moving downward. So minus. If you are taking this direction as a negative, then upward will be a positive. Clear? So 2 plus VB is not given upon 2. V1 is a 1 meter per second. 1. This will be 2 plus VB. VB is equal to 0. So you can say this is the same. VB is a 4 minus 2. VB will be 4. VB is a 4 meter per second. Means this B will be moving with a 4 meter per second. First of all, we found the pulley of velocity of a pulley. Okay, velocity of a pulley from this pulley. So over here we got the velocity of this pulley, which was also for y. Then we write V1 is equal to minus 2 and plus B upon 2. V1 is a 1 meter. Just simplify this. Velocity will be your 4. Now next. Next question is velocity of B. Velocity of B by the diagram. This first, then another first, then another first. B block A is fixed with A rod. Meter per second. This is our case. There are three pulleys. Okay, there are three pulleys. First is fixed, second is moving, and third is moving. There is only one block, which is B. It is moving. With how much velocity block B is moving? This is what question is asking from us. Okay, from us. First of all, say over here. This is your P1, P2. Remember, 20 meter per second. All these strings are fixed with this object. So remember, this will be coming with a 20 meter per second. This will be also coming with a 20 meter per second. This also meter per second. 20 meter per second. This 20 is for each this side, each string. If this is our 20, this will be also 20, isn't it? 20. If this is 20, so this will be our 10, not 10, 20, clear? 20. But this will not be 10 and 10. No. 20 meter per second. Now it's a time to calculate velocity of a B. Velocity of a pulley 1 will be equal to, we are talking about this pulley, which is equal to velocity of A plus velocity of P2 upon try to see over here. Right now we have this one object and second velocity of A, which is minus 10, minus 20. It is talking about this velocity of A, minus 20. Direction is downward. So this one block, second block, third block. Just we are adding velocity of A plus velocity of P, and here velocity of this P pulley is bringing this B velocity. So rather than taking double times, we will take one time. This P plus velocity of A. So Vp, this P1 is not given. This will be as it. Va is a minus 10, minus 20 plus Vp2. Vp2 is also not given. Velocity of this P1 is given, which is a 20. P2 is not given. Upon 2, 40 minus 20 plus Vp2. So 40 plus 20, Vp2. So velocity of a second pulley is a 60 meter per second. With 60 meter per second, this P2 is moving upward. Okay, P2 is moving upward with 60 meter per second. Clear? Now we got a value of Vp2. Vp1 is 20 meter per second. Now it's what about the block B? Block B. So you can write Vp2 is equal to block A plus block B upon 2 minus 20 plus. So 60 minus 20 plus Vb upon 2 120 plus 20 Vb is equal to 140 meter per second. Try to understand what is the answer saying. Answer is saying block B is moving with 140 meter per second. At the same time, this P1 is moving with 60 meter per second, and this first pulley which is fixed by something which is moving, this P note is not moving, okay? Not at all. Clear. So that is how we found the Vp1. Whatever will be velocity of this string will be also for this string. Why reason is this pulley is in equilibrium, which is fixed. But you can't say that 20 meter per second this string, so 20 meter per second will be also this string. No, here pulley is our changing its position. That's why. That's why both will not be equal. Now next we have point method. Point method. See over here. One string will be fixed, and there would be two objects, two blocks, A, B. Second, one point over here, and third point is over here, fourth point is over here. This we are considering as R. First of all, let's explore concept for this bond method. There is a pulley which is fixed by something, and that pulley is bringing two blocks, V1 and V2. In that case, first point is search for the longest string along with the point whose velocity has to be found. Longest, both are equal. Number and mark the points where string touches or loses contact with rigid body. This one point, the second point, third point, fourth point. These are main. Make the sum of velocities of all points equal to 0. This V1, V2 plus V3 plus V4 will be equal to 0. This is the fourth. Sign convention is compulsory. Plus B, positive sign, length of a string increases. If a negative sign is coming as a positive, then understand length of a string. This length of the string will increase. If negative sign, then length of the string will decrease. Okay, will decrease. First of all, you have to find the main points of each end. This one end, this is second end, which is with the pulley, third end, which is with the pulley, and fourth end, which is with the B block. These are 4. And just sum add all these velocities equal to 0. Okay. If answer is coming as a positive, then just understand string is increasing. Let's see. Verification. One pulley. Second pulley. Third pulley. Fourth pulley. And this is last. One block. B block. C block. So C block is moving with 5 meter per second, and A block is going downward with 10 meter per second. C block. Just say points. Okay, points. This 1 point, second point, third point, fifth point, sixth, seventh, eighth, ninth, 10th, 11th, 12. So you can say we have 1 point, 2 point, 3 point, 4 point, 5, 6, 7, 8, 9, 10. Clear? These are 10 points. You know after this what to do. You would say concept says that V1 plus V2 plus V3 plus V4 plus V5 plus V6 plus V7 plus V8 plus V9 plus V10 will be equal to 0. Here velocity of yeah, this is a block. It is not counting blocks. So V4 is equal to, over here, V4 is equal to V5, which is equal to VB, isn't it? Look at over here. V4 is equal to V5. Velocity over here is the same. So velocity of V will be equal 10 meter per second. Try to understand. Velocity of A, 8, will be equal to velocity of 9, which will be equal to velocity of C group. So you can say velocity 8 is equal to velocity 9, which is equal to velocity of C 5 meter per second. But it will not happen with block A. No. Reason is this string is bringing pulley, not a block. Okay, not a block. Here, this 10 was positive, so that's why length will increase over here. Length of the string will increase. Okay, negative sign upward. You are considering downward as a positive and upward as a negative. In that case, everything will be said will decrease. Okay. Meaning of this point is whatever will be velocity of 8 will be equal to velocity of 9, and with the same velocity block C will be moved upward. Next we have V2. V2 is equal to V3 is equal to V6 is equal to V7 is equal to V10, which is equal to 0. Here V2 plus V3 plus V6 plus V7 plus V10, all upward points are equal. We have taken this V4, V5, V8, V9. So don't take again. No, don't take again. We are ignoring V1, okay? V1. So over here we know that velocity of C, velocity of 9 will not be equal to 0. Will not be equal to 0. So velocity of 1 plus velocity of 2, velocity of 3, velocity of 1 is not equal to 0. Velocity of 2 is equal to 0. Velocity of 3, 0. Velocity of 4 is a 10. And velocity of 5 is also 10. Velocity of 6 is a 0. Velocity of 7 is a 0. Velocity of 8 is a 5, but minus 5. Velocity of 9 minus 5 again. Velocity of 10 is a 0. Just calculate all. You will get this will be equal to 0. So final answer will be V1 10, 10, 20 minus 10. So plus 10 plus 20 minus 10 will be equal to 0. So V1 will be your minus 10 meter per second. Minus 10 meter per second. This is our answer. Block A moves upward. Here we just considered upward as a negative. That's why for also B1 block A will be also direction will be upward. If direction is upward, negative will be also negative sign. There will be negative sign for upward. What did we do? Just we found all the marks. V1, V2, V3, V4. Don't take over here because it has a taken point 4 VB. Okay, that's right. Don't take again. So V4, V5, V6, V7, V8, V9, V10, and we know that sum of all the velocities will be equal to 0. Now see over. Velocity of A is equal to velocity of 4 is equal to velocity of 5 is equal to VB. Same with this velocity of C. And just as put a value of each velocities, then say what is going to be velocity of A, velocity of B, what will be your answer? That is all you will solve. If you are considering upward as a negative, then all the times in your question consider that upward as a negative or downward as a positive.